Okay, so for today we're going to look into chapter 3, which is the partial derivative. Okay, so I've already given you all the videos from 3.1 until 3.5. Okay, so if we have enough time, we will look into all the topics. Okay, from 3.1 until 3.5. If not, then maybe some of it, and then we'll continue next week. Okay, let's look into exercise 3.1. Okay, for 3.1 is a function of multi-variables. Okay, so all this while you look into y equals to fx. Okay, y equals to fx means your variables. This is x is the variables, means you only have one variable. But now we are going to look into z equals to fxy, or w equals to fxyz. Okay, more than 2 and more lah now. Okay, for question number 1A, this is the simplest question. It asks you to substitute the value of x equals to 2 and y equals to 2. A value of x and y given, so you just have to substitute into your function. So maksudnya dari kuasa 2 tolak itu saja. So this 2 is for x and the other 2 is for y. Okay, so you solve for this one, you get the answer. And then for B is also the same. You have f, -1 and 7. So the -1 is for x, the 7 is for y. Okay, so okay, and then just use your calculator to calculate for the value. Okay, don't leave your answer like this, because when it is only a scalar, so you simplify your answer until you get one value. Okay, question number 2, it is about domain. So basically we have already looked into domain in chapter 2 kan, chapter 2, which is the vector valued function. We also look into domain. Okay, so if you still remember, to test for domain you only have to test for negative, 0 and positive, in which your function is defined. Okay, you find the domain either negative, 0, positive, where your function is defined. Okay, so let's look into 2a. So I have 1 over 3x plus 1. Okay, so this is a rational function. Rational function tu apa dia? Rational function tu in terms of not 1 over lah. It has a numerator and denominator, atau dalam bentuk pecahan. Rationally pecahan kan? Okay. So rational function, so dia lain lagi. Rational function ni yang penting dia denominator. Its denominator cannot be equal to 0. Okay, because when you have anything over 0, your function is undefined. So means 3x plus y here cannot be equal to 0. Okay, so that is your domain. Ataupun you tulis macam tu je pun dah boleh, atau properly write it in the proper write it properly, it will be xy. Now xy, because you have two variables, x and y. So xy in which 3x plus y cannot be equal to 0. That's it. Okay, so my class this morning asked me, is it compulsory to write the x, y, an element of r to the power of 2? It's not compulsory lah, but what it means is the R2 means you have two variables, so it is in two-dimensional coordinate system. Okay, if only x, then x will be in R, which is one variable, only one coordinate system. Okay, and then it can goes up to R to the power of n. N means n coordinate system. But then what you have learned is only 3D and 3 coordinate system. The coordinate system actually depends on the number of variables. How many variables do you have? Okay, so yang ini ada satu variable x, so r to the power of 1. Yang ini ada dua variable which is x and y, so r to the power of 2. That's what it means lah. Okay, but then you don't have to write these terms in your domain. Okay, enough with this one. Okay, b, fxy equals to 4 over 5x plus exponent 1 minus x plus y the square root. Okay, so exponent actually can take a value of negative, 0 and positive. Okay, however, the power of exponent is square root, and square root can only take a value of greater than or equals to 0. Okay, 1 minus x plus y can only be defined if you have the terms to be greater than or equals to 0. Okay, this one dia tak ada masalah sebab ini boleh jadi from negative infinity until infinity. So you may just discard that one, omit that one, and we look into the domain, the other domain, the other term, which is we have square root. Okay, so you can write down this one as your domain again. df, it is xy, in which 1 minus x plus y must be greater than or equals to 0. You can rearrange this equation. Okay, rearrange maksudnya kalau you nak buat di dalam bentuk y greater than or equals to x minus 1 pun boleh. Okay, kalau tak nak buat pun tak apa, because it is still the same function lah. Yeah, okay. Okay, C, now we have ln fxy equals to ln x plus 2y. Okay, ln, if you use your calculator, katakan ln kosong tak ada kan, it made error. So made error means your function is undefined. So for ln, the x plus 2y, your terms for the ln must be greater than 0 only. Not equal 0, jangan samakan dengan. Sama dengan tu maksudnya dia dah tidak tertakrif. Okay, when you put equals to 0, it becomes undefined. So only greater than 0. So again, this is your domain. X plus 2y greater than 0. Okay, last one, fxy is equals to 9 minus y squared square root. Okay, so again, the 9 minus y squared must be greater than or equals to 0 because it is a square root function. Okay, square root function only defined when your term is positive only. Okay. Okay, so your domain must be in terms of x and y, not to the power of n. Okay, so you have y to the power of 2, right? So you have to solve for these inequalities. Solve inequality. Okay, sekarang ni bisa sama dengan, so 3 tambah y, 3 tolak y lebih besar 90. So the first one you have 3 plus y greater than or equals to 0. And the other one, because it's greater than 1 greater, 3 minus y greater than equals to 0. Okay, or the both is 3 plus y less than equals to 0, and then 3 minus y less than equals to 0. Boleh still jadi positive. Okay, and then you solve lah. You try solve for this one. You will get y in between, because it's 9 kan, 9 punya kuasa jadi 3. Y is in between negative 3 and 3. Okay, so this is your domain. Okay, question number 3 also, we have looked into question number 3 previously in chapter 1. This is a sketching graph, okay? Okay, what is fxy? Okay, as I mentioned before, the z is equals to fxy. Another variable lah, okay? So this is z equals to negative 2. So you have to draw in 3D. Okay, when talk about surface, surface must be in 3D. So untuk you punya test, siapa yang buat 2D tu saja memang salah. Buat 2D je salah, okay? There's no apa markah kesihan ke apa semua tak ada. Memang salah terus kalau you buat dalam 2D because surface must be in 3D. Curve is in 2D. Okay, that's the difference, eh? Okay, so for this one, z equals to -2, so -2, let's say here. How about x, how about y? So again, x is arbitrary, y is arbitrary, so you just draw a line straight parallel to x, another line parallel to y, so this is your plan. Okay, hanging on the z equals to -2. Same goes to b, z equals to 4 minus y, so this is another plan, but this plan will be along x. How do I know it's along x? Because x is missing here. Okay, you only have z and y. Okay, if y is 0, then z equals to 4. If z is 0, then y equals to 4 as well. So we have something like this along x-axis. And then c, okay, z equals to 5 minus 10x minus y. So now there are no longer any along any axis, okay, because every variables is there, x is there, y is there, also z. So you just have to find the intersection point of each axis, okay. So z equals to 5, x equals to 1/2, right? And then y equals to 5 also. So just combine all these points that you plan. D z equals to 9 minus x squared minus y squared square root. So again, whenever you have a square root, for your sketching, it is half of the original surface. So this original surface is actually x squared plus y squared plus z squared equals to 9. But then you only have to sketch half of it. Which half? The z positive. How do I know z positive? Because z becomes the subject and the square root is positive. Okay. So you only something like this. This is 3, 3, and 3. Okay, lastly, e fxy so x squared plus 2y squared, or z equals to x squared plus 2y squared. Okay, so this is paraboloid. Paraboloid on the z. Okay, and it is a what we call smile, the senyum tu naik pada z. Okay, so that's it for 3.1. Basically 3.1 is only introduction to this chapter lah. Okay, the important thing is now, which is 3.2. Okay, so 3.2 is basically the main topic for this chapter, because the chapter itself named partial derivative, and this 3.2 also partial derivative. Okay, what is partial derivative? Partial derivative is a differentiation of a function of more than one variables. Okay, means a differentiation of a function of two and more variables, dua atau lebih. Okay, where you only differentiate respect to one variable and keeping all others as constants. Okay, sekarang ni dia bukan satu, dia mesti ada lebih daripada satu. So dua atau 2, 3, 4, 5 dan seterusnya lah. And then dia jadi partial kerana okay, become partial because you only differentiate respect to one variables. Okay, when you want to differentiate respect to one variables, how about the other variables? We treat the other variables as constant. Okay, itu maksud partial derivative. Okay, so let's look into question 2. Find all first partial derivative of each function. Okay, all first partial derivative means we differentiate respect to one variables. Okay, now we have x and y. So it asks you to find fx and then another one to find fy. Okay, so ada dua variable kan, so kena cari satu-satu lah. Okay, so again, when you want to differentiate respect to x, then your y is constant. Okay. Okay, now we want to differentiate this function, x minus 4y to the power of 6. So we have to differentiate the power 6 first, okay, because the power is the outer ones kan, okay. So differentiate the power, we have 6, x minus 4y, 6 minus 1 equals to 5. Okay, and then you multiply, you differentiate whatever in the bracket. In the bracket now is x minus 4y. You have to differentiate x minus 4y with respect to x, keeping y constant. Okay, so maksudnya sekarang kita nak bezakan x tolak 4y terhadap x, y jadi constant. So bezakan x terhadap x dapatlah 1. Bezakan 4y terhadap x dapatlah kosong. Kenapa kosong? Sebab dia constant. Okay, what is constant? Constant is you just treat your function as one value. For example, if I want to differentiate d over dx 5, you akan dapat kosong kan? Sebab 5 tu constant. Any constant lah. Now, you imagine the 5 you replace with y. Because y is also we treat as constant kan? So, we replace 5 with y. So, it will become 0 as well. Okay, that's how you differentiate partial derivative when you keep one variables or some variables as constant. Okay, so we will have 6x minus 4y to the power of 5. So this one actually can be multiplied with whatever in front lah. Okay, now the front has 6 kan, 6 times 1, then you get 6. Okay, now let's look into fy. Fy means we want to keep x as constant. Okay, so again, before anything, we have to differentiate the power. So 6x minus 4y to the power 5. Okay, times, then we differentiate x minus 4y with respect to x. With respect to y, keeping x constant. So, x yang constant, so bezakan x tu constant dapatlah kosong. Bezakan negatif 4y akan dapat 4. Okay, so again, this one, the negative 4 can multiply with this 6, dia akan dapat negative 24. X minus 4y to the power of. Okay. So basically that's it for partial derivative. Okay, we will continue doing these things. Okay, keeping differentiate one variables, keeping the other constant, differentiate one variables, keeping the other constants. Okay, just with different functions. Okay, for now your function is polynomial. Okay, sebab kuasa. 2b pun sama. The 2b is similar to this 2a because the function is also a polynomial function. Okay, you made it yourself. Let's look into 2c. Okay, so this is a rational function. Rational function, you have a numerator and denominator. Ada atas dan bawah tu kan, pembahagi, pekali dan pembahagi bawah tu kan. Okay, so if I want to differentiate respect to x, okay, you see here, dekat atas ni ada x, dekat bawah ni pun ada x. So you have to use what? You have to use some rules, which is?
Quotient rule.
Yes, quotient rule. Okay, because now we have the variables in the numerator as well as denominator. Sometimes you don't have to use quotient rules, okay, if the variables that you want to differentiate only on the numerator or denominator, okay. Walaupun dia adalah rational function, tetapi kalau atas contohnya y equals to x plus 3y, okay, let's say for example I want to differentiate y equals to x plus 3y. This is rational function. However, whenever I want to differentiate respect to x, I don't have to use quotient rule. Okay, why? Because x is only on the denominator. Okay, so jangan main, orang kata main taram semua guna quotient rule. Sebenarnya boleh juga tapi panjanglah cerita dia. Okay, so let's look into this one. Quotient rule dia macam mana? VU prime minus UV prime over V squared n. Quotient rule. Okay, what is U, what is V? So the numerator as U, the denominator as V. Okay, you tak boleh tukar. Okay, numerator must be U, denominator must be V. You cannot change it because if you change, then your answer will be negative. Maksudnya salah lah kat situ kan. Okay. So what is U, what is V? Kalau saya buat terus ni nanti you tak nampak. Katalah kita buat satu-satu. So tadi U adalah 2x tolak Y. V adalah x plus 3y. Then if I want to find U prime, means with respect to x, right? So I want to find U with respect to x. So saya akan ada 2. 2 saja because the negative y will be 0. Okay. So V prime is Vx, which is 1. Okay, because the 3y again will be 0. Okay, so I just substitute this, okay, into this formula. V prime, so V x plus 3y, U prime is 2 minus U is x minus y. Sepadannya. U V prime is 1 over x plus 3y squared. So you have, simplify lah, 2x plus 6y minus 2x plus y over x plus 3y squared, or the 2x can be cancelled out. What's left is 7x over x plus 3y squared. Okay. And then same with Fy. If you want to use Fy now, the difference is, okay, UV still sama. U awak adalah 2x minus y. V awak adalah x plus 3y. However, when you want to differentiate U, you have to differentiate with respect to y now. No longer to respect to x. So if you want to differentiate with respect to y, you will have 0 minus 1 minus 1. Then V prime is equals to Vy, which is 3. So just substitute the function here to this. Okay, what you have, V is x plus 3y, Vu prime is negative 1 minus 2x minus y, 3. X plus 3y squared. Okay, don't worry, I will give you these notes later. Tak nampak warna hijau ni. Okay. So negative x minus 3y minus 6x plus 3y over x plus 3y squared. So actually this 3y tu boleh cancel out. What's left is negative 7x over x plus 3y squared. Okay. So the difference is only when you want to differentiate. Okay, the other one you differentiate with respect to x. And then for Fy, you differentiate with respect to y. Okay, let's look into 2D. Ini yang saya kata tadi. Tak semuanya kena guna rules. Okay, if I want to differentiate with respect to x, okay, if I want to differentiate with respect to x, I don't have to use the product rule here. Okay, because the x is only on sign. Pada sign saja exponent, there's no x in the exponent, so the exponent will be constant. Okay, so whenever you have a constant, multiply with the variables that you want to differentiate, then the constant still exists. So 3 exponent y to the power of 2, you salin balik. Okay, you salin balik yang tu ya. We only want to differentiate sign to x. So differentiate sign will be cos. Cos 2x and then differentiate again the 2x with respect to x, you have 2. Okay, so this 2 you bring to the front Okay, bukan darab kat sini. Saya dah cakap banyak kali kan, saya think saya setiap semester ada juga yang buat. Kita tahu kenapa. Bukan darab dekat 2x tu Because the 2x is the terms for trigo. Okay, any terms for trigo, it will not change unless you do the identity operation to it. Okay, tambah tolak darab bahagi, it will not change the terms of the trigo. Faham trigo tu dia akan berubah kalau identity saja yang boleh ubah dia. Tapi tambah tolak hasil darab bahagi apa semua dia takkan ubah dia punya tu. Maksudnya if your question is 2x, it will be 2x until the end. Okay? Okay, so your answer here is 6 exponent y to the power of 2 cos 2x. And then for fy now the sine 2x is constant because for the sine there's no y. So every function is constant. So 3 sine 2x is constant. So you tulislah siap-siap. Okay, you only have to differentiate the exponent y to the power of 2. Okay, differentiate exponent is very easy. Okay, because exponent you differentiate dapat benda tu lah juga. Okay, you will get the exponent back. Okay, now the exponent y to the power of 2, you will get exponent y to the power of 2 back. Okay. What's more is you only have to multiply with the differentiation of the power. Okay, now you have y to the power of 2, right? You differentiate y to the power of 2, you'll get 2y. Just multiply with the exponent just now. Okay, so this 2y can be multiplied with 3. So you will have 6y exponent y to the power of 2 sine 2x. Okay, so far do you have any questions? Tak soalan? Okay, kalau tak ada soalan saya nak tanya awak lah. Kenapa tadi constant saya kata dia jadi kosong? Bezakan jadi kosong yang ni kan, constant. Saya bezakan jadi kosong. Tapi yang ni constant ni, bila bezakan dia tak jadi kosong pula. Dia masih ada. Why? Siti Nuatika boleh jawab tak? Tengah makan ke tu?
Tak, medium tak. Tak tahu kenapa.
Tak tahu kenapa. Okay, seorang lagi. Supaya saya tahu awak tak apa? Tak kantoi tengah makan. Irfan Faizal. Kenapa? Irfan Faizal. Ini kantoi, ini orang-orang yang kantoi tengah pasang aja tak dengar betul-betul ni. Okay, Azrul Rahman.
Saya madam.
Kenapa dia jadi macam tu? Yang tadi tu jadi kosong, yang ni tak jadi kosong.
Sebab yang ni darab madam, tadi tambah.
Yes, betul. Bagus Azrul. Walaupun awak memang dengar dari tadi kan?
Dengar.
Okay. Baru nak cakap walaupun. Okay, Alhamdulillah. Terima kasih. Okay, so sebab dia, the reason why, because just now, it is an addition or subtraction. Okay, kalau tambah tolak, dia akan jadi kosong. Contoh d over dx, I have 5 plus x. And d over dx, I have 5x. Okay. The constant is 5. This one is constant. Okay, for the first one, when I differentiate d over dx, 5 plus x, it will be 0 plus 1, right? And when I differentiate d over dx 5x, it will be 5. The constant still exists. This is the constant because the constant attached to the variable that you want to differentiate. Okay, so sama lah sekarang kalau saya tukar y sebagai constant kan. Inilah katalah yang 5 ni sekarang saya tukar y. y tu yang jadi constant. This is y, this is y. So maksudnya kat sekarang ni yang ini jadi kosong, yang ini still akan jadi y lah, exist lagi y dia. Okay? So that's the difference bukan semuanya awak taram jadi kosong bila beza kan. Asalkan constant kosong, asal constant kosong tak. Okay? If the constant is attached to the variables that you want to differentiate respect to, then it still exists. If the constant, okay, the variable that treat as constant stand alone, it's a stand-alone variable. Okay? Do not attach to the variable that you want to differentiate respect to, then it will be 0. Okay, that's the difference. Okay, so for 2e, saya rasa tak ada masalah lah ni. 2e ni awak boleh buat sendiri because it is only a square root. Okay, square root means it is to the power of 1/2, to the power of half. Okay, so you have to differentiate the power first and then you differentiate whatever in the bracket with respect to either x or y. Okay, let's look into question number 3. Okay, so again, question number 3 is also a partial derivative. However, it is in terms of application of the partial derivative, which one of it is a slope. Okay, slope in the x direction and in the y direction. So kalau x direction maksudnya fx, in the y direction maksudnya fy. So you cari saja fx dan juga okay, ini tak masalah lah ni because it is the same as 3e tadi So katalah saya cari satu saja. Okay, this is equals to 2x squared plus xy to the power of 1/2. Okay, it's better if you put the power outside because it becomes polynomial. So to differentiate polynomial is very easy lah. Okay, you just bring the power to your front first, 2x squared plus xy, and then the power minus 1, which will become -half. And then you multiply with the differentiation of whatever in the bracket. Now in the bracket we have 2x squared plus xy. You want to differentiate respect to x, so the xy will be 0. Again, why? Because there is no x there. It's only xy, so the whole xy will be 0. And you differentiate the 2x squared, akan dapatlah 4x. So yang ini boleh potong 2x, so 2x over 2x squared plus xy half. Okay, I write down because this is -1/2, right? -1/2 means the square root is become the denominator. Okay, and then the question asks you to find fx to 1 at the point where x equals to 2 and y equals to 1. So 2 times 2 over 2 times 2 squared plus x. Okay, 8 tambah 8, 16, 16, 4, 4 dan 4 sama dengan 1. Okay, so you may try for fy to 1, try Okay, now question number 4 is higher derivative. Higher derivative means either fxx, fyy, fxy, and so on. Okay, it depends on how many variables there are. Okay. So fxy equals to 4xy squared plus 3y minus 2x squared. Okay, so I want to find fxx. Okay, before finding fxx, I have to find the fx first. Okay, And then my answer to the fx, I will differentiate again respect to x. Okay. So dia mesti ambil daripada jawapan terdahulu. Okay. So fx is equals to, so again x means y is constant. Okay, so this y is constant, however it attached to x kan. So 4y kuasa 2 tulis siap-siap sebab dia constant. Biasa kalau constant yang attached dengan variable ni, kalau kita tak tulis siap-siap, kita akan tertinggal. So tertinggal tu salah lah, okay. So to avoid that kind of careless mistake, so you have to write down it in the beginning before you differentiate your variables, okay. Now we want to differentiate x, get 1, and then the 3y is 0. Okay, why? Because there is no x there, only 3y. So the whole terms is a constant. So it will be 0 minus 4x. So I have 4y squared minus 4x. Okay, and then I have to differentiate again my function with respect to x. So I'll have 4x lah, negative 4x. Okay, yang ini maksudnya saya ambil daripada atas ni With respect to x again so the 4y squared will be 0 lah. So dapat negatif 4 saja. 4 fxy pula saya akan ambil daripada yang sama juga, which is from here, but then I want to differentiate respect to y pula sekarang kan. So differentiate respect to y, you akan dapat 8 y lah, bezakan ini dapat 8y, bezakan negatif 4x dapatlah 0. So this one is 0 minus 4, which is negative. This one is 0. Okay, so question number 5 also the same. You have to do it yourself. Okay, but then the question number 5, saya kena tunjuk because it has x exponent xy. Okay. Fyx. Okay. So now let's say I want to differentiate with respect to y first. Fyx kan? Fyx or yw. Okay, so again the 5x squared is constant. Tulis siap-siap. Dia akan 5 y kuasa 4 tambah. Okay, this one, if you want to differentiate with respect to y, it will be you don't have to use product rule. You don't have to use product rule because this is x is constant. So you treat this x constant. Tulis siap-siap. What you want to differentiate is only the exponent xy because the y is only attached to exponent. Okay, so you tak perlu nak guna product rule kat situ Sebab kadang-kadang student ni dia nampak semua variable, semua dia nak guna product rule. But then you have to remember that the variables is treated as constant. Okay, so when constant, it become constant lah. How you treat the constant, that's how you treat your variable x right now. Okay. Okay, so exponent again, exponent xy, exponent beza dapat exponent lah juga, tulis je balik kuasa dia semua tu, and then you bezakan sekali lagi, you darab, you bezakan kuasa dia pula. Now we want to differentiate the power xy with respect to y. Okay, with respect to y, mean x constant, right? Okay, so you tulis balik x tu, y you bezakan dapat 1. So this is the how you differentiate the xy with respect to y. Do not left out the x because x is attached to your y, your variable that you want to differentiate with respect to. So x will have a plus x squared exponent y. So this x actually you can multiply with this one lah. Okay, so fyx is, now the y is constant. Okay, you take your variables from this one y is constant, so saya tulis 25 y kuasa 4 tu siap-siap, saya bezakan 2x saja, x kuasa 2 dapatlah 2x, and then from this part, okay, I have to use product rule. Okay, why do I have to use product rule? Because I want to differentiate with respect to x. Now I have x here, x polynomial, and another x in the exponent. So I have two different functions which use variable x, and it is a multiplication of two different function. Okay, so you have to use product rule. So product rule is u v prime plus v prime. Okay, let's say this is our u, this is our v. Saya tulis terus kalau you tak dapat nak tangkap, you buatlah satu-satu tu. U apa dia, v apa dia. Okay, but then saya nak tulis terus. Okay, now you want to differentiate with respect to x, y is constant. So tulislah y, differentiate x dapat 1. U v prime plus v u prime. Okay, that's it. So I have 20xy to the power 4 plus xy x to the power of 2y exponent xy plus 2x exponent xy. So this is your answer for fyx. Okay, so for fxy, you may try it yourself, right? Okay, 6. Now I have 1, 2, 3 variables, x, y, and z. Cos x, y, z plus y to the power of 3, z to the power of 4 minus exponent yz. Is it? Okay. Let's say I choose to solve question A. You may try for B yourself. Okay, del squared w over del x del y is actually del over del x del w over del y. Okay, so difference from the other notation just now, in this one you have to solve the back term first, the terms in the back. Okay, so you have to solve del w del y. Means if I write down in terms of f tadi kan, this sekarang bukan f lah, w. Okay, because the variable is w. When I write down in terms of w, it will be w y x, not w x y. Okay, that's the different notation in between when you write down in terms of del, or when you write down in terms of variables. Okay. Okay, so for del w del y, now I have two other variables as constant, which is x and z. Okay, so y tu kat sini, y tu kat sini, and then y tu kat sini. Semua kena beza. Before I differentiate the x, y, z, I have to differentiate cos. Differentiate cos will get negative sign. Okay, and then multiply, differentiate whatever in the bracket with respect to y. So the xz is a constant. You tulis siap-siap, differentiate y dapatlah 1. So macam tu And then plus z to the power 4 is constant. Okay, so attached to the variable that you want to differentiate, so dia masih ada lagi, dia tak jadi kosong. And then y to the power of 3 will be 3y to the power of 2. And then minus, okay, again exponent, whatever power is the exponent has, you have to differentiate. When it is the differentiation of exponent, just write down the exponent back. Okay, and then differentiate the power, multiply with the exponent. Now we want to differentiate with respect to x, so z constant. So z lah y dapat 1. Okay, so I have negative xz sine x, y, z 3y squared z to the power 4 minus z exponent yz. Okay, so we differentiate again this one with respect to x. Then we will have, okay, this one has x, this one also has x. So we have to use product rule here. Okay, del over del x is actually, you want to differentiate this one. Okay, with respect to x, betul lah tadi negative z Okay, so this one, it has no X, so akan jadi kosong. And then this one also, there's no X, right? Only have Y and Z, so everything will be a constant, so it will be -0 as well. So this one only will be your answer, which is negative Z sine XYZ minus XYZ to the power of 2 cos XYZ. Okay. Okay, in this part, please do it carefully lah. Be careful on this part lah, because this is a product rule with so many variables, but you only have to focus on one variable, which is the variable X. So Y and Z will be constant. Okay, you may do 6B yourself, the del squared W del X squared. Okay, let's look into 7. Question 7 is a wording question, application question that uses partial derivative to solve the problem lah. So I have a volume of cylinders V equals to pi r square hash, where r is the radius and hash is the height. And then question A asks to find the formula rate of change V with respect to r. So del V del r. Okay, obviously when you want to differentiate with respect to r, hash is constant. So pi 2r hash lah jadinya, bezakan r kuasa 2 saja. And then B, find a formula rate of change V with respect to hash if hash changes and r remain constant. So pi r kuasa 2. Suppose that hash has a constant value of 5, so hash is equal to 5 inch, r varies. Okay, and then the question asks to find del V del R when R equals to 9. So del V del R, actually we have to use from A saja lah. R equals to 9, hash equals to 5 means 2 pi R equals to 9, hash equals to 5. So you have 9. Okay, for D, suppose that R has a constant value, R equals to 9 inch, but hash varies. Find the rate of change of V with respect to hash. Okay, so find del V del hash at the point when hash equals to 5. So again, this del V del hash, you take it from B. You have already solved it, so you just use that one. Pi r squared. Now the r is equals to 9. So pi 9 to the power of 2, which is 81. Okay, so you may do question 8 for yourself. I don't think there will be any problem for that one, but if you do have problems, you may ask me through WhatsApp later. Okay. Okay, so that's it for partial derivative. So again, for partial derivative, as long as you know how to differentiate one variables and keeping all other variables as constant, okay, there will be no problem for you. As long as the basic of differentiation means the differentiation for polynomial, for exponent, trigo, ln, okay, and for the quotient rule, product rule, semua tu kalau you tahu, insyaAllah tak ada masalah untuk selesaikan partial derivative. Basically, it is the same as derivative, differentiation, the ordinary differentiation, okay? The difference is only, the constant is in terms of variables, okay? Not in terms of numbers, okay? Itu saja beza dia. So, biasanya kita akan keliru lah, ni constant ke variable, but then, you have to collect yourself together back lah. Kalau you rasa keliru, stop dulu, tengok balik. Mana satu variable, mana satu constant. Okay, and then you keep that in your mind. Constant as constant, variable as variable, then you have to differentiate variables only. InsyaAllah tak ada masalah bagi awak. This is 3.2. Okay, we have 1 hour more. So before we proceed with 3.3, do you have any questions so far? Okay, let's look into exercise 3.3. Now we are in chain rule. Okay, there's 8 questions altogether, but I will choose random questions now. Question number 1. Kita pergi yang paling senang dahulu. Okay, I have z equals to x squared y, x equals to negative t squared, and y equals to 2t to the power of 3. The question asks to find dz dt. So chain rule ni maksudnya dalam satu variable tu ada variable lain lagi. Okay, in one variable it has another variables. Okay, so it is a chain lah. Okay, rantaian. Okay, now in chain rule the important thing is to do the tree diagram. Okay, if you can master this tree diagram, I can give you 100 of variables and you still can do this chain rule, no problem for you. Okay, the tree diagram is the first one. It has z, okay, and then under z it has a variable x and y. Variable not the function. Jangan tulis x kuasa 2. Okay, do not write the x to the power of 2. X to the power of 2, x square is the function. We only want the variables, which is x and y now. And then under x there's t, and then under y there's also t. Okay, you tengok macam ni lah. Dalam bawah x tu ada t, bawah y tu ada t, tapi bawah z tu ada x, ada y juga, ada 2 variable. Okay. Okay, so if the question asks you to find dz dt, okay, you gabungkan, okay, just combine whatever chain that link z to t. Okay, z here, t here. Okay, just combine this chain and then another chain here. Okay, so dia macam tree diagram, macam pokok lah, dia ada dahan-dahan ni kan. Okay, the same chain here. Okay, this is del z del x. Okay, differentiate the upper variables with respect to the lower variables. Now the upper variables is z, the lower variables is x. This one del z del y. Okay, and then this part, okay, dia akan jadi dy dt, and then this part dia akan jadi dx dt. Okay, the same chain, okay, chain yang sama ni awak darab, chain yang berlainan ni awak tambah. Okay, itu saja. So kalau ada banyak chain awak tambah lah, tambah banyak kali. Okay, so dz dt is actually del z del x times dx dt plus del z del y times dy dt. Okay, what is del z del x? Okay, means you want to differentiate z with respect to x. Look into your z equation, which is z equals to x squared y kan. So y tu akan jadi constant, tapi y tu darab dengan x tadi kan. So constant ni tidak akan jadi kosong. Okay, constant ni dia akan attach, dia masih juga ada, and then you differentiate x to the power of 2, you have 2x. So 2xy kat situ. Okay, differentiate x with respect to t, dia ada negatif and negatif 2t lah. Okay, tambah differentiate z with respect to y. So again the x squared is constant. So differentiate y dapat 1. So 1 lah. So dapat x kuasa 2. Darabkan dengan differentiate y with respect to t. Y is 2t to the power of 3 kan. So bezakan 2t kuasa 3 ni dapatlah 6t kuasa 2. Okay, so we have negative 4xyt plus 6x squared t squared. Okay, so often sometimes the books dia tinggal macam ni, tak apa. Okay, and then there's another books, like in your module, you must write in terms of the last variable. The last variable is t kan. Kalau ada lagi variable lepas t ni, okay, tulis in terms of that variables. Okay, it must be in terms of the last variables. Now, how do you want to change the x and y into t? You use this function. Okay, so kan jadi 4x negatif t kuasa 2, y is 2 to the power of 3 times t plus 6, x tadi apa, negatif t kuasa 2 lagi times t to the power of 2. Okay, barulah dapat jawapan dia. Tambah 6 t kuasa 4, 5, 6 t kuasa 6 juga. So 8 t kuasa 6 tambah 6 t kuasa 6 dapatlah 14 t kuasa 6. Okay. And then you can do B by yourself. Okay, B tu dia ada ln, ada power juga. So before you differentiate the power, you have to differentiate the ln. Okay, ln will be 1 over x plus 3y squared squared. Okay, and then times differentiate whatever in the bracket which is x plus 3y squared. Okay, so bezakan yang itu. Sebelum bezakan itu, bezakan kuasa dia dulu, baru bezakan yang tu. Okay, so B, try it for yourself. Okay, but then I give you a sneak peek on the ln, on how to differentiate this ln. Okay, first of all, you have to differentiate ln ni dulu. So, dia akan jadi 1 over x plus 3y squared squared. Okay, and then multiply. You differentiate apa? Differentiate yang ini pula. Tapi dia ada kuasa dulu kan. So, 2x plus 3y squared, the power will be 1. And then differentiate lagi. Dia banyak differentiation ni. Differentiate lagi yang dalam ni pula. With respect to, kalau x, x lah. Kalau y, y lah. Okay. So, katalah saya nak bezakan terhadap x This one. With respect to x. Okay. So, dia akan jadi 1 tambah kosong. Kenapa kosong? Sebab 3y squared tak ada x kan? So, the 3y squared, the whole term is constant. Okay, so when you differentiate constant, you will get 0. Okay, so actually this one and this one, you boleh cancel out because x plus 3y, ini pun ada x plus 3y tapi dia ada kuasa 2, so dipotong. So what's left is 2 over x plus 3y squared. Okay, you try. This is only for ln, and then dia ada lagi square root t and t to the power of 1 over 4 kan. Try that one Okay, question number 2 pun you boleh buat sendiri lah ni sebab the function is only polynomial. Okay, so I think you don't have problem for polynomial function. Biasa student dia ada problem dengan function selain daripada polynomial. Ln pun ada problem. If the function is square root pun ada problem. Actually, square root tu boleh jadikan kuasa 1 over 2, 1/2. Okay, and then when you change it into the power of 1 over 2, it becomes polynomial. So you only differentiate the power and then bring the power to the front and so on lah. Okay. Okay, let's do the question number 3. So this question is in terms of wording. Okay, application. So kita akan tengok yang ni. Volume of a box. Okay, so volume of a box is given as XYZ kan. Tapi XYZ tu adalah, so dia bagi length, kita gunalah length times width, lebar times height dia, tinggi dia. Okay, so panjang darab lebar darab tinggi. Okay, volume untuk box. Okay, so the information given is L is 5 and the volume is changed. What volume is okay, and then dl dt is equals to decreasing, and so decreasing means negative 4. And then when w is 3, dw dt is increasing 3. and then the height is 2, and the hash dt is increasing 1. 4, 3, 1, 5, 3, 2. Okay. So at what rate is the volume of the box changing? So the question asks us to find dV dt. So dV dt actually, before you want to differentiate v, you have to before you want to differentiate with respect to t, okay, you have to differentiate v with respect to L, and then you plus differentiate v with respect to W because it has 3 different variables, right? So you have to differentiate with respect to all the variables. Okay, so how do I get this? From tree diagram, So actually you write down this this function, no, this formula. Okay, you already got 1 mark for it. Okay, so formula dia ni berubah-ubah, depends on the function. Depends on the variables. Okay, the formula is changing depends on the variables. So dia tak ada satu formula yang fix. Okay. Okay, so dVdl is actually differential respect to L. So W hash is the constant, still there. dL dt is -4. And then dV del V del W, dW dt is 3. Del V del hash is LW. And then dH dt is equals to 1. Okay, so tinggal lagi masukkan nilai 532 ni saja. So 3 darab 2, 6, darab 4, 5 darab 2, 10, darab 3, 5 darab 3, 15, darab 1. So get 21. Okay. Question number 4, 5, 6, you may do it yourself. Okay, benda sama saja. Make sure you bring out the information first. You write down all the informations given, and then find the rate of change that the question wants. Okay, either if it is dVdt ke, dVdr ke, dVd hash ke, depends on the questions. Okay, contoh macam nombor 4 ni, suppose that the portion of the tree is right in circular cylinder. If the height of the portion is increasing, d hash dt is increasing 3 inches per year, and then the diameter dd dt is increasing 2 inches per year. How fast is the volume? So soalan suruh cari dv dt of the portion of tree increasing when the height, when hash mana hash equals to 40, d equals to 10. Hash equals to 40, d equals to 10. So before anything, you have to find the volume of a cylinder, which is pi r square times hash. Okay. So to find dVdt, so actually to find dVdt, you have to find del V del R times dr dt plus del V del hash times d hash dt. Because you have 2 different variables, so each variables must be differentiated. Okay. Okay, but then the question gives you d, which is diameter. Okay, how do you find radius from diameter? Okay, so diameter is actually 2 times radius, or radius equals to d over 2. So dr dt 2 bagi 2 dapatlah 1. So yang ini apabila d equals to 10 means your r is equals to 10 times divided by 2, which is 5. So you use this information to find the dv dt. Okay. Same as question number 5 and question number 6. First of all, you have to find the formula that can be used to differentiate. Okay, for example, this one. This is the the volume formula, the volume of a cylinder, because the question wants to find the rate of change of the volume. So kita guna volume lah. Okay, for this one, the question has to find the rate of change of the volume of a box. So volume to box lah. Okay, and so on. Okay, for question number 5, actually the formula is already given, which is PV equals to XT. Okay, PV equals to XT, so we use this formula. The pressure, volume, and temperature are related to the question PV equals to XT. Use chain rule to find the rate at which the pressure is changing. So dia suruh cari dP dt, sebab pressure tadi P kan. When temperature the pressure T, temperature T ni, when T equals to 120 Kelvin and increasing dt increasing at the rate of 0.2 Kelvin per second, and then the volume is 40 liter and increasing at the rate of 0.15 liter per second. Okay, so you find dP dt. So it's easy if you left your equation in terms of P. So 8T equals to P. Okay, so to find dP dt, so actually you have to find del P del V times with dV dt plus del P del T times with dt dt. So every info here, substitute into this formula. Question number 6, two straight roads intersect at the right angles. Intersect at the right angles. So right angles means 90 degree lah. Okay, ni road pertama, ni road kedua. Lorry A moving on one of the road approaches the intersection. Approaches the intersection at 50 miles per hour. Let's say yang ini lorry A. Okay, intersection tu kat sini, intersection. So katalah ini X, ini Y. So dx dt adalah 50 miles per hour. And lorry B kat bawah ni dia moving. So dy dt adalah 20 miles per hour. At what rate is the distance between lorries changing? So distance between lorry tu adalah diukur berdasarkan hypotenuse pula. Pythagoras yang ni So because as the lorry dengan lorry ni, as the lorry is approaching the intersection, the distance will be decreasing lah. Makin lama makin kurangkan distance dia. Okay, dia pun sama as it's approaching the intersection, the distance will be decreasing. Okay, so let's say distance ni SD. Okay, kita guna theorem Pythagoras, it will be x squared plus y squared square root. Okay, so use this formula. Okay, so question wants to find dd over dt when A, x is 3 and B is 4, y is 4. Okay, so use this one, try. Okay, one more question. Let's say I look into question 7. 7 and 8 is similar questions. It is a problem of two variables. Okay, more than one variable, which is two variables. So I have z equals to xy squared minus plus 7x. Then the x is 2u minus v, and then the y is 2v. Okay, so as usual, you just use the true diagram. Okay, the upper one I have z. Okay, and then under z I have two variables, which is x and y. But then now under x I also have two variables, which is u and v. Y also have two variables, which is u and v. So if the question asks you to find del z del u, you only have to look into the chain that connects z and u. So z dan u kat sini lah, z dengan u kat sini lah. Okay, omit the v lah, just ignore the v. Sebab tu saya kata kalau ada 100 variable pun dia tak ada masalah, because you only have to look into that one variable, the other one just ignore. Okay, so del z del x times del x del u plus del z del y times del y del u. Okay, so I want to differentiate respect to x, y kuasa 2, y constant tambah 7. And then x, want to differentiate respect to u, the v is constant, so times 2. And then again, the z, now we want to differentiate respect to y, so I have 2xy minus 2 plus 7, 7 is 0, 7x is constant, so 0. dy du, so v. So I have okay, and then the question asks to substitute the value of u equals to 1, v equals to negative 1. Okay, so 2y squared plus 14 plus 2xy minus 2 negative 2. Sebab v ni negative 1, so darab dapat negative 2. So y equals to 2 tambah 4 plus tolak 4xy tambah 4. Sampai sini ke jawapan awak? Bukan. Okay, you still have to find the x and y. How to find the x and y? Okay, you have to substitute the value of x and y. Okay, use this one. Okay, means if u equals to 1, v equals to negative 1, okay, x equals to 2 minus minus 1, which is 2, 1 minus negative 1, which is 3. And then y equals to 2 times 1 times negative 1, which is negative 2. So substitute that one into our equation. So dapatlah 2 darab 2 kuasa 2 tambah plus tolak 4. X is 3, y is negative 2. So negatif lah, tapi negatif kuasa 2 dapat positif juga. Tambah so we'll have 50. So your answer must be in terms of constant only maksudnya jangan lupa yang part ni. Student selalu lupa kat sini. Part ni awak cari dapatlah 1 markah, awak masukkan nilai dapat lagi 1 markah. Okay, so basically 2 to 3 marks you left out kalau you tak buat yang tu And then the del z, del v, okay, please try find it by yourself. As well as question number 8. Okay, question number 8 also try. Question number 8 also has 2 variable, which is r and theta. Theta tu variable juga dia Okay, so basically that's it for 3.3, which is the chain rule.